Hello and welcome. Today, we're exploring a fascinating shift in how we understand monsoons, those life-giving seasonal rains that billions depend on. For a long time, we thought monsoon timing was mainly down to changes in solar radiation. But recent research is pointing to something else: atmospheric memory. A groundbreaking study published in May 2025 by the Potsdam Institute for Climate Impact Research reveals that monsoon systems worldwide, including the critical Indian southwest monsoon, effectively have a memory. This memory isn't an abstract concept, it's tied to the cumulative buildup of atmospheric moisture over time. Imagine this stored moisture as a reservoir. It influences when monsoons switch on in spring and switch off in autumn. Researchers combined observations with simulations and found that the atmosphere's current state depends on its seasonal history. So, even as the sun's energy fluctuates, the atmospheric response isn't immediate. Water vapor gathers for days and weeks during spring, and this stockpile determines when the monsoon rains begin and helps sustain them even as solar input wanes in autumn. This lag, where a system's response is shaped by its own history, is a phenomenon called hysteresis. For monsoons, it means if it's already raining, it's more likely to continue. Conversely, dry conditions make it harder for rainfall to start. The study also identified a critical threshold for this atmospheric memory. When atmospheric water vapor content goes above approximately 35 kilograms per square meter, the monsoon tends to switch on. If it drops below this, it switches off. This sharp, threshold-based behavior suggests monsoons can flip between two stable states, wet and dry. Remarkably, simulations showed monsoons can flip between these states even without the thermal inertia traditionally thought to be provided by oceans. The atmospheric moisture column itself is the key, acting as the system's tipping point. The monsoon crosses this tipping point annually and then returns, a unique characteristic among climate tipping elements. Now, while atmospheric memory is a significant advancement, it's part of a bigger picture. Other factors influence monsoon rainfall, like the moist static energy budget, shifts in the intertropical convergence zone, interactions with the land surface where soil moisture can create a land memory, wind evaporation feedbacks, and even the effects of vegetation and rising CO2 levels. Anthropogenic factors like greenhouse gases and aerosols also play a huge role, sometimes leading to a wet get wetter scenario. The discovery of this atmospheric memory has profound implications. Disrupting this delicate balance, especially the moisture tipping points, could be catastrophic for agricultural and water security. However, this new understanding also opens doors. We might be able to identify monsoon tipping points using observational data and develop early warning systems. Continued research into the interplay of atmospheric memory, circulation patterns, land-ocean atmosphere interactions, and climate change impacts is vital. Understanding these complex dynamics, including regional variations like how westerlies affect Central Asian monsoons, is key to improving predictions and managing water resources in our changing world. Thanks for tuning in.